Hello students, I am Dr. Mamta Barik, Assistant Professor in the School of Management Department in IMS University Course Campus, Ghaziabad. Today I am going to discuss a topic, correlation with you. In this video, I will discuss introduction of correlation, types of linear correlation, correlation coefficient, limitation of correlation coefficient and its real life application. So, when two variables are said to be correlated, if the change of effects of one variable affects the other variable, then the two variables are said to be correlated. So, when the two variables move together, whether in the same direction or in opposite direction, they are said to be correlated. So, it is a statistical technique used to determine the degree to which two variables are related, and it is developed by the statistician Francis Galton in 1985. For example, price and demand of a product. Correlation analysis provides only a qualitative measure. That means it tells us that the two variables are correlated or not. It doesn't specify the cause behind that and what is the effect of relationship between these two variables. Now, types of correlation, types of linear correlation. First is positive correlation. When the two variables deviate in the same direction, that is, on increasing one variable, other variable increases, or on decreasing one variable, other variable decreases, such a relation is called positive correlation. For example, relationship between height and weight, or price and quantity. In this data, it is clear that both the variable, in first data, both the variable are increasing, and in the second data, both the variables are decreasing. They deviate in same direction. Also, one more example is when the trees cut down, number of trees cut down increasing, the probability of erosion also increases. Second is negative correlation. When the two variables deviate in the opposite direction, that is, on increasing one variable, other variable decreases, or on decreasing other variable, another variable increases, then the relation is negative. Correlation is negative. For example, relation between price and quantity, relation between demand of a good, or the sale of woolen garments in when the day temperature increases. In the first data, when x is increasing and y is decreasing, and in the second data, x is decreasing while y is increasing. For one other example is, if a car decreases speed, the time taken to reach the destination increases. Next is zero, no correlation. When there is no linear relationship between two variables, then the correlation is zero or not, no correlation. That means a change in the value of one variable has no particular effect on the value of other variable. Next is perfect correlation. When two variables change in the same direction and in the same ratio, then there is perfect correlation. While if the two variables change in the same ratio but in the opposite direction, then there is a perfect negative correlation. Now, coefficient of correlation. Correlation coefficient is a numerical value that shows the degree or extent of correlation between two variables. It lies between -1 to +1. For positive correlation, it lies between 0 to 1. For negative correlation, it lies between -1 to 0. For perfect correlation, it is 1. And for perfect negative correlation, it is -1. Correlation coefficient doesn't change with change of origin and scale. Now, degree of correlation. If R is perfectly 1, positive 1, then it is perfect positive correlation. R is -1, it is negative, perfect negative correlation. When R lies between plus 0.75 to 1, then the correlation is high. And if it lies between -0.7 to -1, 0.75 to -1, then the correlation is highly negative. When the R lies between plus positive 0.25 to 0.75, it is moderate. When it lies between -0.25 to -0.7, it is negatively moderate. When it lies between 0 to plus 0.25, then the correlation is very low. And when it lies between 0 to -0.25, it is also low in negative direction. And when R is 0, there is no correlation, no association. Method of measuring correlation. Whether there are various methods in this lecture, we will discuss scatter diagram and Karl-Pearson correlation coefficient. Scatter diagram is a graphical representation of bivariate distribution to determine the nature of correlation between the variables. For positive variables, in scatter diagram for positive variable, the straight line goes up in upward direction, and in negative correlation, the straight line goes in downward direction. And when all the points are very close to this line, then the correlation is highly positive, and when there is a gap between the points and the straight line, then the correlation is low. And when the straight line goes in the downward direction, it is negative. In the same way, when the points are very close to straight line, it is highly positive, high degree of negative correlation, and when there is a gap between them, then the degree of correlation is lower. And for perfect positive correlation, all the straight line goes in upward direction and all the points lies on the straight line. In negative correlation, the straight line goes in downward direction, and for perfect negative correlation, all the points lie on the straight line. And in the case of no correlation or zero correlation, all the points are arranged in a very haphazard manner. And Karl-Pearson correlation coefficient, there are three methods: actual mean method, direct method, and assumed mean method. For actual mean method, R equals to summation xy upon under root summation x square into summation y square, where x is division of x with respect to its mean, x minus x bar. Similarly, y is y minus y bar. In direct method, R equals to n summation xy minus summation x into summation y upon square root of n summation x square minus summation x whole square into n summation y square minus summation y whole square. In the same way, in assumed mean, we replace x by dx, division in x, and y by dy, and in the step division method, we replace x by d dash x and y by d dash y. Here dx, dy, d dash, d dash y, they are the division with division in x and in y respectively. Dx is x minus a, dy is y minus b, d dash x is x minus a upon h, d dash y is y minus b upon h. Here a and b are assumed mean from x and y respectively, and I is the length of interval, and n is the total number of observation. For example, we have given a data. In this, firstly we write the formula. We use a method, write the formula, the method we have to use. In this question, we have used direct assumed mean method, and according to our method, we construct the table. We construct the column which we required. Like as in this, we required dx, dy, dx into dy, d square x, d square y. Find all the values of dx, dy, d square x, d square y, dx, dy. Find their sums. Put all the values in the given formula, and we get r equals to 0.98. It is positive, therefore the relation is positive, and it is 0.98. It lies between 0.75 to 1, therefore correlation is high. Next, we can calculate correlation from our Excel sheet also. Firstly we mark our data into column, like as we have marked our data in the column E and F, and we use the formula equals to Corel. Then in bracket we select our cell, we put our cell address, and press enter. We get the value 0.774299. It is also positive and its degree is high. It's real life application. Correlation coefficient is used in time spent on e-commerce website versus money spent by a customer, number of unique user versus sales in a day. Measure the correlation between patients' blood pressure and medication use. Thank you so much.